This little device represents possibly the biggest leap in auto bed leveling technology that I've ever had the pleasure of using. So let's talk about it. This is the Beacon H Contact. It is an eddy current scanner for your 3D printer. Unlike a probe that will go at a fixed point and measure it a few times and move over and do the same thing, this thing is able to rapidly scan your bed and give you an extremely detailed mesh in just a matter of seconds. Watch this. Now we have to home our axes first, and watch what it does. It's going to use our end stops for our X and Y, and then it's going to use the nozzle as a probe. That gets us our Z offset automatically. If I go ahead and hit calibrate, we'll get our bed mesh. It's going to do one pass, and then when it scans the whole bed, it'll do a second pass. You can have it set to do more passes than that if you want. You can also increase or decrease the grid mesh that it does. I have it set to do a 5x5. And if we look at the data, we have our bed. And look at just how detailed this data is. Each one of these squares represents a point that traditionally you would have to probe individually. But with this scanner, we can use eddy currents to get that information for us at a rapid pace. So you might ask yourself, just how accurate can something that goes that fast possibly be? Well, pretty accurate as it turns out. I was able to do this with literally zero input from moi. That means I got the Z offset, relative positioning, temperature drift, all that automatically calibrated for and taken care of by the Beacon scanner, and automatically put down a nearly perfect first layer without really anything from me. Besides programming the automation and getting CAMP to just barely not go off the grid when I made this. Yeah, this thing is doing really good. I've done several tests with it so far, and so far I've not had many problems. Keyword, many. I have had some problems. The reality is this device is extremely sensitive. Almost to a point where it's obnoxious. Let me explain. Here's the thing. This system allows you to use the nozzle as a probe, allowing you to automatically get your offsets. That's great. But if there is anything, and I mean anything, on that nozzle that is not brass nozzle or whatever your nozzle is supposed to be made out of, it's gonna think that's the nozzle. So if you have an itty bitty little piece of plastic that oozed from your last print on the tip of your nozzle, that's gonna offset too. It's gonna be the nozzle plus the ooze, and that's gonna mess up your offset. Here's another thing. It's anything that is rigidly connected to the Beacon. That is what can be used as a probe. This is how sensitive it is. This Beacon is connected via a mount to my direct drive extruder. The direct drive extruder is connected via an MGN12 linear rail that connects to the X-axis. What's also connected to the X-axis? This thing, my auxiliary fan. Watch what happens when I attempt to home and I have something like the auxiliary fan touch the ground. Right, so I'm going to attempt to show you guys what I mean. I'm going to use the gantry as a point where I just put my finger, and you'll see what I'm talking about. If we home all the axes, and as long as one requirement is satisfied, that being that the eddy current shows as a metal surface underneath it, the red light will show up here, and then I can use my finger at any point on anything that's rigidly connected. See, that's one. I can use my finger. I can use I can use the aux fan if I wanted to, but yeah, it's very sensitive, and it'll basically try to get 3 consistent samples within a certain standard deviation. If it cannot get 3 consecutive standard deviation samples within a certain percentage of each other, it will throw out that data and attempt to do it again. So it takes 3 samples, and then if it doesn't work, it retries it. That was for 3 samples, and then it does its final sampling on the very end with the 4th touch after it's calibrated the probe. So it scans fast, it scans accurate, and it's really good at setting the Z offset. So what's not to love about it, right? That being said, if there is one very compelling reason to go with Beacon over Cartographer, it is the phenomenal tech support and community behind the product. There's more people making modifications to printers to support this than there are Cartographer at the moment. Some of the documentation on the Beacon website, I think, needs to be updated for the Rev H version of the product. That being said, when I ran into issues, I just went on the Annex Engineering Discord, and the people there were phenomenal. They helped me lickety-split. We're talking ASAP. I got it done in a matter of a few hours, and I didn't think I would have this done in a matter of days. Here I am enjoying it. That being said, if price is a problem, these do go on sale. I got mine on Black Friday for 20% off of the normal price. So then the question remains, is Beacon right for you? Well, it's not a simple yes or no question. In order for the Beacon to work, your build surface has to be conductive. PEI on spring steel, perfect. G10 with nothing underneath it, not gonna work. If your build surface is not a thick, flat magnet like this, and you have embedded magnets every few millimeters, then that's not going to work either. Those embedded magnets will interfere with the eddy currents used for the scanning process. There is a time and a place for everything, and if you're using specialty building surfaces that are not conductive, then yeah, a standard probe like a BL Touch might actually be what you need. However, if you're like most of us and you have PEI on spring steel, oh man, this works perfect. The thicker the spring steel, the better. But because we probe using the nozzle every time we print, we can swap out build surfaces from flat PEI to textured PEI. We can change our nozzles and do whatever we want, and it's automatically going to adjust for those changes. In the end, I paid real money for this product. I had real headaches with it, and I solved all of them thanks to the amazing support and community behind this project. So quite frankly, if you meet the prerequisites where you have the correct build surface and you're familiar with Klipper, go for it, man. You're not going to regret it. This thing is amazing. It has completely changed my entire process. This is now one of those printers I can hit print and walk away and be 90% sure the first layer is going to go down fine. So if you've made it this far into the video, you were clearly curious to see how this little product works. Well, I hope I answered that question for you. Here on this channel, we don't review 3D printers, we review 3D printer components. If you want to see more videos like this, get subscribed. And if you liked this video, please give me a thumbs up. It really helps me with that algorithm nonsense. And as always, I'll see you guys in the next video. Measure twice, print once.